round. I'll go through these review questions. We're going to recap some of the histology that we've already covered. So it shouldn't be, most of this stuff shouldn't be brand new information. So muscle structure shouldn't necessarily, sliding filament theory will be, and the muscles, this is going to, I've got all the handouts that we've done so far, all the labels, so that shouldn't be new information, that should be a recap. The only new part will be muscles of the face. And then that's it. And then open clinic this afternoon. I will always leave your sheet up here by the side, by your cabbies with the names of who's doing what. So you're welcome to have a look at that when we finish, like at break time, so you know what time, because we've got 2 time slots. First group are in at 1 p.m. and then the second group are in at 2:15. So you've got 15-minute turnaround. You'll only be doing 1 treatment. Once you finish your treatment, if you're first, you just close off your curtain and work in silence, so that there's no disruption. But you just get on with theory in the afternoon. Okay, cool. So review questions. Let's have a look. What did we get? Question 1. Let's go round. What did you get? Which of the following bones are part of the appendicular skeleton? A. Scapula, humerus, clavicle, and radius. Did we all get that? What did you get?
I didn't put anything. I left it and come back to it. I was hoping it might come back to me.
So, do you remember I was saying to draw your little man? Do you guys get that? So, what bones are part of the axial skeleton?
The trunk.
Yeah, your trunk. So, your skull. What else? Spine, vertebrae, and ribs. That's your trunk. So that means your scapula and your clavicle, your collarbone, your arms, your pelvis and your legs are all part of the appendicular. Yeah, limbs, I've done that a bit more detailed, but as long as you know your skull, vertebrae and ribs are your trunk, axial skeleton, the rest is appendicular. Therefore, you should have gone through there and seen A, that's got none of the axial, but B, what is axial in that answer? Sorry? Cranium, which is the head, and ribs and coccyx, it's the lower part of your spine. So we know it's not B. What is in the axial of C? Ribs, sternum, it's, that thorax area, and what's in the axial in D? Vertebrae, yeah. Cool. So, question 2, long bones do what, Charlie?
Produce blood cells.
Produce blood cells, yes, nice one. Would this be in the epiphysis or the diaphysis? Epiphyses, which are the ends, yeah. Which of the following is an example of a long bone? Maxine, what did you get for this?
Is it all on number 3?
Yeah.
Phalanges.
Phalanges, yes. Where are your phalanges? Fingers and toes, yeah. So it doesn't matter how little they are as long as they're in proportion. So your phalanges could be small, really, in relation to your femur, but it's still thin. As long as it's thinner than it is longer, it's a long bone. What is the shaft of a long bone known as? Just told you this, Linda.
I know, well, I just changed it then because I had that wrong. So it'd be the diaphysis.
Diaphysis,
Yeah.
yeah. What's the periosteum?
That's the bit that goes
Around.
Yeah.
What's articular cartilage?
Goes at the end.
That caps the end,
Yeah.
also known as hyaline cartilage. It's like a white kind of semi-transparent capping that enables fluidity within the joints. And obviously the epiphyses are at the end, yes. So question 5. Which of the following is classified as a short bone? Ada? Not C. Anyone else? D, yeah. Because phalanges is what? Long. Scapula is what? Flat. Vertebrae is irregular because the size of your C1, C2 is so different from the size of your L4, L5 because it's much more about structure and weight bearing, where C1, C2 is much more about mobility. And therefore, the whole shape changes because of its function. So therefore, it has to be irregular. What number are we at? That is a tricky one, though. I would give you that. It's a kind of a curveball. But that's in the mock egg. So one of the questions in the mock egg.
Sure which one, but I'm saying probably.
Yeah. It's a tricky question. Question 6. Tash, what did you get? How many vertebrae make up thoracic spine? 12. How many vertebrae in cervical? 7. C1 to C7 is that bony bit that sticks out the back of your neck. 12 in thoracic. How many in lumbar? 5. How many in the sacrum? 5. Why is it 3 to 5 in the coccyx?
Because not everyone's quite as evolved.
Because it depends how evolved you are. You can't have, if we're talking about a dog, or like someone on all fours, right? You don't have your tail there. Yeah? You've got cervical, C1 to C7, thoracic, T1 to T12, lumbar, sacrum, coccyx. Your tail is at the end. You can't have a tail midway through your back. It has to be by your arse, it's the lowest point. So you're not going to have, oh, maybe you're a bit more evolved, so your mid-back is sticking out. No, it's the final question, the final part. Cervical has how many?
7.
Thoracic has how many?
12.
Lumbar?
5.
Sacrum?
5.
5. Coccyx?
3 to 5.
Yes! 3 to 5. But it's at the end. Which of the following describes the knee joints? Tash, you should answer. Una? B. A hinge joint allowing flexion and extension. Did you say that? Yeah. So your answers are there. These are all on the PowerPoint. It's up on Moodle. So
have to do all of them?
Huh?
Do we not have to do all of them?
Yeah. But I'm just saying,
Oh,
if you
sorry.
wanna, I can upload this mock exam. The whole mock exam is up anyway. But if you wanted to have a little recap and test yourself, just so you know you got the right answers, but hopefully you've got more on the sheet anyway. Okay, let's go through question 8. Charlie, the atlas and axis is an example of what? A pivot joint, yes. C. Question 9 to 13. Match the joint actions with the correct description by inserting A to E in the boxes provided. There is no box, so let's go with it. Question 9. Linda, what did you get?
E.
E, then
C.
then
B.
then D.
A.
Yes.
Yes.
Did we all get that?
Yes.
Nice. That one is tricky. I've said this before, how these questions aren't particularly worded well, but that is an example of what it could be like. Vaccine and meniscus is what?
A.
A fibrocartilage pad that provides padding between bones. Nice. Ada, 15.
B. Bone to bone.
Yes. Did everyone get that? Yeah, nice one. Which organelle of a cell manufactures proteins for use within the cell? What did you get? D. Ribosomes. Yes, it's the part of the cell that manufactures protein. Mitochondria is the what? Mighty powerhouse. Yes. Lysosome is the
No.
I can't remember what they
Oh,
do.
let's things in and out? No.
that will be the cell membrane.
I'm just going through them all now.
Lysosome. It was a little green sac.
See where
Thing,
it
where
is on the
What's the
diagram.
Yes, the lysosome. It digests all the crap, so it's the dustbin man.
It's a dustbin.
The nucleus is what?
Controls the cell.
Control centre, and ribosomes manufacture proteins. Yes. Voluntary muscle is also known as what, Tash? Skeletal. Nice. Yes. Up there, just in case. Question 18. Which of the following is the deepest muscle of the abdomen? Nuna. Sorry? Rectus abdominis would be the most superficial. Yeah, so it's nearest, the rectus is nearest the skin and the transverse is nearest the spine. The Transverse is like that belt, that corset. What's the function of the rectus abdominis?
Extension of the spine.
That would be the function of the back muscles, the rectus spinae. This is the antagonist. So what does this do? Originates here, inserts here.
Flexion.
Crunches crunches. So flexes the spine. Flexes the trunk. So you've got the deepest is the transverse, then what's nearer the skin? Next layer. Internal obliques. External obliques. Rectus abdominis, yes. Number 19, where is non-keratinized stratified epithelium found? Yes. Charlie.
Wet surface.
Yes, wet surfaces such as the mouth and conjunctiva of the eye. Because keratinized, if something's keratinized, it means it's what?
Dead.
Dead. It's like this protective layer. Therefore, on the inside of your mouth, it's wet and much more vascularized, so it's not so dead. Which one of these are also known as stem cells, Linda?
Oh, I put D.
Yes.
But I only know that because we had discussed it. I don't know the cell stuff enough, so I know I've got to go over all of that.
What is the function of the osteoblast?
They're the ones that create.
Yes, they build what?
Blood cells.
Osteo?
Oh, bone.
Bone.
Yes.
So osteoblast builds bone.
Yeah.
Ossification is the process of what?
Is that?
I thought that created bone.
Because the blast creates,
But
and then it's
osteoblast is kind of a type of cell that blasts it out. Ossification is the process of bone making. Endochondral
Yes.
ossification. But that's a process, that's not a cell. Osteoblast is a single cell. You can see, you can't see a physical process. That's like several stages. Endochondral ossification is where cartilage turns into bone. And we had that example of where we have that epiphyseal plate, so it grows in length. That is the process of ossification, it's bone hardening. Whereas an osteoblast just builds. So that's the osteoblast. B is ossification. C, osteocyte does what? Kills. So kills up all the old ones. And then mesenchymal is a stem cell. What is a stem cell? Not a neuron. It's what all type of what tissue starts as.
The first of the embryon is missing.
Sorry?
The creators of the creators.
Yeah, in a way. So connective tissue has two things in common. It all starts as a stem cell, a mesenchymal cell, and it all connects. So a mesenchymal stem cell can choose what the body needs. Does it need to be blood? Does it need to be cartilage? Does it need to be bone? So stem cell is what connects all of, it's the one thing that all connective tissue cells have in common. They all start as a stem cell. They all start as a mesenchymal stem cell. What movements happen within the sagittal plane? Ada? Flexion and extension. Maxine, what plane of movement does abduction and adduction happen on?
Right, 2 seconds, I think. Abduction and adduction is frontal plane.
Yes, nice.
Sorry about that.
Um,
Fire blue.
Tash, what plane does internal and external rotation happen on? Cross, yeah, transverse. What is circumduction?
Oh, I was thinking about that the other day, and I couldn't. And I was like, "What the hell is that?" I couldn't
You
remember.
can all show me what circumduction is by moving your shoulder. The clue's in the title.
Rotation.
Circumduction.
Rotation, but
I was doing that. I just couldn't do
Flexion,
it off.
extension, abduction, adduction, internal, external rotation. Do it all.
Yes.
Circumduction.
Yeah.
Which plane is that, though?
Circumduction is what hits all planes. You know in what quadrant of the body is the gallbladder? A, correct. Upper right quadrant. Did everyone get that? quadrant, you need to know your quadrants. So for revision, if you're not fully confident on that, you need to go back and have a look. So because there is always a question that comes up about quadrants. The triceps muscle does what? Yeah, what are you doing? Extending the elbow, Charlie, an agonist is a muscle that what?
I didn't know this one.
What did anyone else get?
Contracts, pulls, and action.
Yes, Charlie, if I said to you, my tricep is the agonist, what's the antagonist? Would you know what an antagonist is? An antagonist, anyone else?
Opposite.
Is the opposite mover. So the agonist is the primary mover. So if I say extend your elbow, the triceps does that job, therefore it's the agonist. It's basically the muscle we're talking about, the primary mover. The antagonist is the opposite. So like Una was just saying, rectus abdominis flexes the trunk, so the erector spinae is the antagonist. What is the antagonist of the abductor muscle group? Adductor muscle group. If one group takes away, one group must add. Yes. What number are we on? Over. So last page. Your answers. What is the correct order of hair growth, Ada? What does anyone else get? A. Act is how we remember. ACT is you're in alphabetical order. Hair is made up of protein. Keratin is a dead structure. Longitudinally, the hair is divided into 3 parts. I just want to make sure that this is written correctly. Yeah. What did you forget? What did anyone else get? I put A, and then I was like, oh no,
Could it be something to do with the skin and then the root and then
Yeah.
Jesus?
It is A. So basically, the last part of this, the last page and a half of this exam, the computer wasn't saving, so I was doing it on college computers. Thank the Lord for Macs. The one thing I was doing at college, and I was like, save, because I write it all in and I change it all around. And I was like, it's not changing. So yeah, that is why it's all AAA.
That's funny.
So obviously, question 27, melanin is a what? Dark pigment corrects from DNA. It's in the deepest layer of the epidermis, basal layer. What are the 5 layers of the epidermis?
Corneum.
Yeah. Yes, come let's get sunburned.
I
was
thought
trying to
about
do that
that.
now.
Yes, all of your little things.
3 a.m.
really
I went through
helps.
that in my brain.
Good work. What is mitosis?
T for 2.
T for 2. So 2 identical daughter cells. What is the process called where you do not have 2 identical daughter cells? And it's for meiosis. It's for sex cell reproduction, gametes. It's meiosis. What is supination? Palms up to the sky. What's the opposite of supination?
Pronation.
Pronation. Yes. Nice work.
Sorry, I didn't actually do 28. I didn't actually read
A. Mitosis. Kim, we've just been going through our review questions for today.
Oh, yeah. I've got one. Charlie's given me one.
Oh, cool. Brilliant. Perfect. So we're gonna. I do have a few spare. If anyone wants to go over them, I would recommend doing this again for your homework. Get 100%. If you keep getting the same ones wrong, don't just memorise the answer. I want you to go back to that part that we have looked at and get to know it. If you really can't understand it, you can book a tutorial on with me. We can meet 15 minutes before class or after class. You can look on YouTube. You can get some books. Get your head around the process. Don't just memorise the answer for the exam. Like, learn it, understand it. Teach someone else is the best way to learn it. And then go back to it again and hopefully you understand it.
Can I ask you a quick question?
So the stem cells, you say that's what everything, all connective tissue starts as.
Yeah.
So it can become. So then, what did you say?
All types of connective
So
tissue.
all just.
It can become a bone cell. It can become
Whatever it needs to be.
cartilage
did you
cell.
say?
It can become a blood cell. Like anything
Yeah.
that your body feels like it needs. We did go through this with tissue types. So I think that was LO1B.
Okay.
So if you want to go back on Moodle and have a look,
I need to go over.
LO1A is where we did the cell,
I do too.
Yeah, and that one.
and LO1B was where we looked at histology. We looked at all the different types of tissues. If you have a look in your logbooks and you look at your anatomy and physiology unit, so the logbooks I said was like your Bible, that has to be nice and clean at the front of your books. If you actually look on there, it will state kind of the information you need. Have a read of that as well if you want to just.
Can I ask just a question?
Yeah.
That on the board that you've just drawn, is the blue appendicular?
Appendicular, yeah.
Appendicular.
And the
what's
red is axial.
Axial in red.
Yeah.
I did get that, but I did get it right, but I just couldn't remember what the names of it were. Axi, what is it? AXI.
AXIAL. Okay, so looking at the muscles. Muscle tissue makes up about what percentage of the body's weight, do you think? Almost. You're within 10%.
What was it? What did you say? It's 70, isn't it? Or not?
50. It's about 50%. How much do you think of the muscle is water?
This is high.
High, much higher than 30.
70.
Higher.
Oh,
Left.
the whole body.
80. 75% of your muscle mass is water.
Wow.
And you've got about 20% that is protein and 5% that are minerals, glycogen and fat.
Only 20% protein. So what is it?
So muscle tissue is what we're looking at today. Is anyone any good at technology and knows how I can...
The top bit should be able to move.
Do you want to give me a hand? I feel like this is expensive equipment.
Yeah.
I don't know.
Not moving.
Does the little flap on the end move?
This?
Yeah.
No. I
I think it's had a bit of bump.
Does it
It
need
just
to
needs
move
to be moved
forward?
over.
The actual ball. Does the whole thing move or not? It looks really heavy.
don't know. The whole thing is attached, isn't it?
Oh yeah. So just move the whole
Let's just see how we go with it. Okay, so how many types of tissue are there?
3 muscle tissue.
Yeah, what are they?
Skeletal.
Skeletal,
Cardiac.
cardiac, smooth. What one lines your internal organs? Smooth. Anyone else?
Yeah, it must be smooth.
Smooth, yes. Is it striated?
No.
Let's have a look. What would you say is this type of tissue? It is striated, so these are your clues. It's striated, it's got one nucleus that's in the middle of the cell, it's got a branching structure. We haven't really covered that so much, but intercalated discs, that's not important so much because you already know the structure looking at that. What type of tissue is this? Cardiac. So it's found
I can see the bottom corner picture.
round organ.
in the heart. Is it voluntary? Involuntary, yes, it's cardiac. There is your answers. What type of tissue is this? So uninucleated, so it's got one nucleus, packed tightly together, no striations. What is it? Yes, where's it found? Give me an example. Digestive system, yeah. Is it voluntary? No. Correct. And final one, this type of tissue is skeletal, yes. So long straight cells, obvious striations, obvious stripes happening, multinucleated, like multinucleus, it's got is on the outside of the cells, and found in, it's a skeletal muscle because it's attached to your bones, so it pulls on the bones. So this was the recap. These are the images from VT-CT, so we've gone through these already. Any questions so far on tissue? No? Happy with that? Nice one. So the structure of a muscle. So when you're looking at a cellular level, so I like the way it's like bulging biceps. Bulging biceps, if you look at the whole muscle, this has all little bits in between called a fascicle, and these fascicles are made up of muscle fibers. The muscle fibers are wrapped in a perimysium. Peri means around. Anything myo is what? Muscle. Perimysium, it goes around the muscle fibers. Perimysium. The entire muscle itself is surrounded by epimysium. Epi means on top. And then you've got the muscle fibers wrapped in perimysium, and within the fibers you have got myofibrils. Each one of these is covered in a sarcoplasmic reticulum, which I will explain. Within the myofibril, you have myosin and actin. Has anyone heard of these before? No. This is the concept of the sliding filament theory. With the whole muscle system, I think you'll be absolutely fine, but this is the trickiest part to get your head around. So don't stress about it if it's not making sense straight away, because it does take a while. I know it took me quite a while to get my head around it, but I'll talk you through it. So we're looking at the sliding filament theory. What I'll do is I'll show you this slide first. So this is all you need to see. So you've got a muscle. Can you all see my screen here? So you've got the long muscles, right, that we were saying. You've got the nucleus on the outside, and they have, the stripes are called what? Striations. These striations are called your Z lines, because what you have is a sarcomere. So you have these Z lines, and that is actually, when you zoom up on a microscopic level, what these striations look like. But when you zoom out, it just looks like lines. You can just see a definition. So that's what this are. Within the sarcomere, you have these thin rope-like structures. And these rope-like structures are called actin. Actin are the thin, they're a protein, so a thin protein, and on top of these, or in between these, you have myosin. So you have these other proteins are in between. What happens is the rope-like structure actin acts as a binding site. So myosin climbs up the ladder, climbs up the rope, comes in together. So eventually, so you've got movement happening, and the sarcomeres come closer together. So when a muscle is extended and then it contracts, all the little sarcomeres contract together, and then you have a much shorter muscle. Therefore, you're in a concentric contraction. The muscles come in together. So right now, all my Z lines are getting closer and closer together. When you stretch, the Z lines get closer apart. Do you understand how that could work? If you've got loads of these. So if I was stretching, my Z lines would be further apart. And then when I contract, Z lines now get closer together. That's basically how muscle contraction works, and it comes down to this cellular level. So I'm going to explain a little bit more about this actin and myosin. The way I'd recommend thinking about it is actin is like Action Man. He is rope, a thin rope-like structure. He's slightly skinnier than the regular Action Man, I'd say, from what we are familiar with. More of a Peter Crouch kind of acting. Not our regular hench guy, but a little bit slimmer. So that's actin. Myosin is, I'm going to call her Miley. I don't know how you spell Miley, but I'm going to spell her like that. Miley is like the girl. Basically, these are Romeo and Juliet. They are desperate to be together. And Miley, I'd say, is much more keen. She just wants to cling on and cling on. She's like this needy, obsessive girlfriend. So what happens is there is a molecular currency that gets involved. Any idea what that molecular currency is? ATP, adenosine triphosphate. I'll write it up here. ATP adenosine triphosphate is the currency that your body works with. So this is your US dollar of your body. So adenosine triphosphate. One thing you need to know is that proteins will change shape if something attaches to them. Generally within the entire body. Proteins can change shape when something attaches to them. So what we've got happening here, I'm going to explain on my next slide, and I'll just show you here. So can you see here, these are the Z lines? So if you were to zoom out, that's how you'd get those stripes. So you've got the thin Action Man here, and then the red is Miley, and think of a ladder. I kind of think of it like, more like this. So if actin was a bit like that, so that Miley has kind of got something to go in, like a little hole to dig into, like the rope is kind of bumpy, so it's almost like these rungs of a ladder so they can climb up. So what happens is, if I take you back to this slide, so you've got actin is the more rope-like structure, so you can see this purple rope-like structure here, which is your Peter Crouch style Action Man, and then Miley has got these two heads here. So what happens is, if you can see these heads, you've got the myosin has collected some ATP. What does that stand for? Adenosine triphosphate. Can we all say it? Adenosine triphosphate. Adenosine. Kim? Yes. Adenosine triphosphate. So you have this ATP. Ignore this right now. I'm quite happy that's been chopped off. So ATP. So you've now got something that is attached to a protein. It's going to change shape. What this ATP is, it recoils Miley and winds her up so she is ready to pounce. So she has clinged back. Peter Crouch is bracing himself. And then what happens is ATP is used, it's broken down. This is the energy cycle. What you have is triphosphate. You have adenosine triphosphate. So say you have 3 molecules there. When you use your energy, it gets broken down. It actually becomes adenosine diphosphate. And then you get something else added on. So it's 2 and a 1. So you don't really need to know that process, but that's adenosine triphosphate is in the original state of energy, adenosine triphosphate. So just think of like adenosine triphosphate as $1, and then you go and buy something, and now you get back loads of change. Like you're not getting a single dollar note back. You're just getting loads of random coins, and it's now separated. So that's obviously not how it works, but that's what I want you to visualise. Is adenosine triphosphate is the original $1 currency, nice and neat. That's how it's packaged. You then use it, then it gets broken down into all these different ways that it can be used, but it's all recycled back into ATP. ATP has a finite amount, so that is used for very quick bursts of energy. So if you're going for a full-on sprint, you can't keep that up for 800 metres. A sprinter's time is very different to someone that's running an 800 metres, and it's a different energy cycle. And we'll go through that later on. But just so you're aware, when you're reading this, I know you can't see it here, but that says ADP for adenosine diphosphate. So you've got ATP. She's now taken, she's got the dollar. This means that she will recoil, ready to pounce, into ADP. So from now, she uses that, clings on to the rope, and then drags herself along Peter Crouch. Give me a snog. And then her job is done. She is released, waiting for the next lot, the next $1. Comes back, gets the ATP. This means that something's attached to her, so she's going to change shape. Therefore, she recoils. She pounces again. And this happens to every single head along the rope. So eventually, the force of several miles climbing up the rope is going to cause the muscle to contract, so the sarcomere gets smaller. And this is happening all over your body. Every time you blink, you chew, you stand up, you walk. It's an insane process that you think, bloody hell, I have no idea how this is happening, but adenosine triphosphate is needed. There is a lot more that's happening. You can see these blue dots. Are you with me so far, by the way? Kind of got the process. You just need to know that the binding site, which is where Miley binds onto, is called what? Who is Peter Crouch? Actin.
Yeah.
Actin is the binding site. He's like the foundation, the strength. She's the one that binds. She's the needy one. The binding site itself is actin. That's all you need to know. If you wanted to know a bit more information, I would look into tropomyosin and troponin. Because what actually is happening on this rope-like structure is another level of complexity. Have you heard how muscles need calcium to move and contract? So what you have is, when we looked at this level, so we've got the epimusium around the entire muscle. You've come through and you've now got the muscle fibres, each one wrapped in a perimusium. It comes through to a myofibril, and that is wrapped with sarcoplasmic reticulum. This sarcoplasmic reticulum enables calcium to flow into the muscles. It's called a T-tubule, but we're not going to go into that much detail, but just if you want it, I'm going to talk you through it.
Would we need to know that diagram, the previous one, for the exam or not?
No.
Oh, good.
So what you have is, these blue dots are calcium. What happens is, you have got troponin and tropomyosin. So can I rub this off? So troponin and tropomyosin are basically the mum and dad of Miley. Have you heard Craig David, that 7 Days song? Oh, no, it's not 7 Days, is it? It's you know, like when he's talking about the parents. What? I'll have to think of the song. He's like, there was like a red bottle of wine and then it's gone, and then that's just how I think of this. That's how it works.
We had a bottle of wine and then it was gone.
Listen to, your homework is to listen to Craig David and tell me next week. So what you have is, this is Peter Crouch, the rope-like structure. Who is that? Actin. Yeah. I'm going to show you, so on here, what is actually happening is you have this kind of protective layer which covers it, called tropomyosin. Tropomyosin is like a kind of a barbed wiring, let's say. which is clamped down by these nails called troponin. So we know ATP is the molecular currency. So molecular, that's what is needed to fire up myelin. Who is who? Myosin. So actin and myosin, in order for that relationship to happen, ATP is needed. But there is another part of the story, which is tropomyosin and troponin. Troponin is the nail in the barbed wire, basically. It's clamping down the tropomyosin. I think of troponin as the mum and tropomyosin as the dad, because basically of Miley's mum and dad. If troponin, the mum, is fed, let's say calcium is equal to a bottle of red wine. Right. So yes, me too. So you've got all this calcium that's dotting around. So troponin, the mum is like, go on, I'll have a glass of red wine. She has a glass of red wine. She's had some calcium. Then she's like, oh, and let's say this is at 5 a.m. or 2 p.m. in the afternoon. Miley's like, Mum, I really want to see Peter Crouch. I really want to see acting. She's like, don't even think about it. Stay in your room. You're not going. Suddenly, the mum's all had a glass of wine. It's 8 o'clock at night. She's had a bottle of wine. Before you know it, troponin's like, oh, go on then. I'll let you off. So as soon as troponin lets off, the dad's like, I'm still not sure about this. And the mum's like, listen to me. They're going. Just let them off for once. And the dad's like, oh, go on then. In our family, if my mum says something's happening, my dad has no choice. So basically, the mum rules the roost. So once this nail lifts, tropomyosin lifts as well. So now, so basically the mum and dad were guarding Peter Crouch. Suddenly, they've buggered off. Peter Crouch is free. Miley's like, get me $1, get me the ATP, let me climb up him. Troponin's like, oh, my glass of wine is worn off, clamps back down. So you need calcium in your blood and to be able to fuel troponin and tropomyosin so they can release, so that when you get the ATP in the currency, Miley can crawl up. So that's how it works on the cellular level. So when we look at the endocrine system and we look at, for example, calcitonin, which is a hormone in your blood, and how you've got these opposite levels where, say for example, you've got no calcium in your blood, you can barely move your muscles, your body will start breaking down your bone so osteoclasts come in, they kill down some bone so that everything can be reabsorbed, all the nutrients, all the calcium that bone had is reabsorbed into the bloodstream just so that your muscles can function. So you need to have calcium in your system for healthy bones and healthy muscles, so everything's got a rich supply. So hence why diet is so important. But it becomes sense when we learn the endocrine system, everything kind of comes together and we kind of realise why all these things are happening. But do we kind of understand the concept of actin and myosin? What is the binding site? Actin.
Oh yeah, acting.
He is the site. He is like, you come to me. Like, he is the cooler one of the two. Miley is the one crawling up. Okay, so that is your sliding filament theory. So this is all happening within the sarcomere. Sarcomeres come together, muscle contraction. Hence those Z lines, which define the start and the beginning of each sarcomere. That is the striations. Hence why you know that is skeletal muscle. And cardiac muscle works in this same way, but it's a different kind, because it's cardiac and it's just for the heart. It works in this way, but we don't control the movement. It's involuntary. This is voluntary, but smooth muscle does not work in this way because it has no striations, so it can't work in the same process. Okay, I'm just going to quickly whiz through this. All or none law. So when a neuron receives an impulse, all the muscle fibres within the motor unit are activated. The motor unit will only activate the fibres it controls. For other muscle fibres to be activated, more neurons and motor units would be activated. What is a neuron? what type of cell?
Stem cell.
No.
Mesenchyme.
That's what all connective tissue starts as. This is a nerve cell. A neuron is a nerve cell, part of the nervous system. Basically, what this is saying, when a neuron receives an impulse, all the fibres, if this is a group, if this is one motor unit, say you have your quads, for example, these are your big, strong muscles for walking. So that might have like 1,000 myofibrils in it. So that when you get one, only it's innovative, so it's only got one neuron, it's only got one kind of fire to say work, and my entire quad can fire up and start working. Otherwise, if it had thousands, it would take you so much more to just walk, simple process. But you can have the same quad, and I can lift it really slowly because my nerve signal is going to be like this. So move slowly, move slowly, move slowly, or it can be like bam. So it's just like a signal. So you can have like this going, or that's if I'm like being really slow, or if I'm like, come on, sprint, someone's chasing me. Then it's exactly the same process. It's the same muscle fibers firing. It's just my neuron is saying work faster, work faster. Whereas strength-wise, if I am to try and pick this up with my little finger, I might at the beginning try, and I've got like, so obviously the more detail, the smaller that area is, so like around your eye, your fingers, because you've got more dexterity there, they will have a lot more neurons firing because they've got lots of little muscle groups for control. I don't need to have as much control with my legs just walking. So therefore, if I'm trying to write and like really draw something really intricate, I'll need lots of little units, lots of little firings of neurons to help me. But if I'm trying to lift something, so at the moment I'm only using one motor unit, sorry. It's not enough. So I need to recruit I can feel my body contracting another set of muscles, and then another set of muscles. So that's kind of how this system works. And what that does is the fact that you fire, you get a signal from your brain saying go slow or go fast. But it's the same muscles, they're just getting different instructions. But it's what means that, like, if I'm using my forearm muscles, I get the same signal from my brain as when I stroke my kitten. So I've got to be very gentle and light, as if I was to crush a cow. It doesn't mean I'm firing up the exact same motor unit, but in my head, thank God, my brain is saying, this must be really gentle whispering. Otherwise, if I'm trying to crash, like, or if I'm doing like a weights class, it's like, come on, work, work. It doesn't mean that I'm using more muscle. It just means I'm using the same muscle group, but I'm getting a different instruction. So you have these motor units. You won't be expected to know that in your exam. I doubt they'll ask you that, but that's just what this is explaining.
So if someone had motor neuron disease, that doesn't work for them. So their muscles waste because they don't work, I guess.
Yeah, so we'll look at this when we do the nervous system. But you have sensory neurons. And so if I was to touch this, it would be boiling. The process that happens is my skin, my sensory receptors feel it. That signal goes up to my brain. My brain processes that, and then I have a motor neuron which moves it, which goes back down and says, lift your hand up. But that literally happens like instantly. So you have sensory neurons, I'm going to work out what's going on, a motor neuron, bloody arm close, and get burned. So that's how it works. So motor neuron, their sensory neurons work.
Yeah.
They can receive the sense, but they cannot do anything about it. My uncle had motor neuron and was living with us for a few years, and it is horrific. And his wife, so my aunt is Japanese, and she's like this beautiful, delicate little woman, but she's like smaller than you, she's tiny, and he was heavy in the end. So like in trying to get him from the wheelchair into bed, dead weight, but
Yeah.
he's still got all the sensory neurons firing. So you can feel everything is sensitive because you've not got the muscle mass that even protects. So anything you hit or anything, you still feel it, but you can't do anything about it. So talking, you can't eat. Is eating out of a straw, like being like fed through a straw, like you can't pick anything up. Your brain is still 100% active. And you are trapped in this. It's the cruelest disease. I think. If you ever do a charity or if you ever do a marathon, please run for motoring because it's like there's not that as many sufferers as cancer, for example, and therefore it won't get as much funding. So it's a really good charity to work for. But but this is why they're looking at stem cell, mesenchymal stem cell work and research because
they're doing transplants or something, aren't they?
yeah, and it's really sad because if we like have any damage somewhere in other cells, some cells can recover, but they're not exactly sure, are they? Like, and why the motor neurone breaks down exactly.
No.
There's no cure for it.
So it's hereditary, and it all can be hereditary.
Yeah, I mean, there's no previous history in our family, but I don't know, healthy guy living the dream in Hawaii,
And then that
no
happens.
kids, no stress, and you don't know why. Like, it's just mad. But something is happening on the outgoing signal. The incoming signal works, but the outgoing isn't. But we look at that a lot more when we look into like the nervous system, and there's a lot of pathologies that can happen there. Your homework is to complete your 3 pathologies for the skeletal system, like normal.
We've done
So,
that, haven't we? Or not?
sorry, the muscular system.
Haven't we done muscles and... Oh no, was that just...
You will have done 3 pathologies for the skeletal system. Just as we go, week by week, I'd like you to complete that. So this is a question in your exam. In skeletal muscle, the thin contractile protein filament, known as the binding site, is what it says. Containing the binding site is known as what? Actin. Yes. Last one here, arches of the feet. This will come up in your exam. What are the functions of the arches of the foot? What do you think the arch is there for? Stability, support the weight of the body. Yeah. That's what the arches of the feet are there for. So plantar fasciitis, for example, or let's say if you get fallen arches, what do you think fallen arches can be caused by? Bad shoes, yeah. Weak muscles. Why would they become weak? It's generally obesity. The increased weight means your feet can't handle it. So the arches can no longer support the weight of the feet. So it happens quite a lot in pregnancy, especially if women are having twins and they've got all this excess weight. And then it can, especially if you're pregnant, it can kind of ease off obviously after you've had the kids. But generally fallen arches happens with increased weight.
What if you've always had, like, if you're almost born with it, you know, like, some people are just flat-footed. Don't really have much of an arch.
Yeah,
You
it
know,
can
like,
be.
even from childhood.
It can be like a genetic thing. And like some people are naturally supinated or inverted or everted. So there can be reasons like that. But like we were saying, like you need to help yourself
Yeah.
and not just rely on
it.
like manufactured arches to string your shoes. You need to contract and work the muscles. You need to be walking as much as you can barefoot. When we come back from a break, we are looking at the muscles of the face, and then it's just a recap. So let's go team.
About 20 presses.
How come in the winter I get these things like this?
Oh yeah, I would do that, because that's like if you haven't done it.
Yeah, because I haven't done anything.
Yeah.
Honestly, my arm.
Yeah.
Fingers and toes. I usually get
Yeah,
Yeah, I had a blowout tire this morning. But it could have been worse, so at least it wasn't tire. I was able to stop it because it was so far back. How cute to change it. Okay, that's good. It took about an hour because we had to go and get some race just a few minutes later because I left at 8:30. Okay. Imagine so stressful. Yeah, it wasn't too bad. I would have been at the 5 this morning. I was
Salads. Yeah. It's annoying, isn't it? You all get itchy. Yeah. So you take it really
yeah, me too. Please tell me on first.
My sister gets them as well. She gets them worse on her toes.
It's done.
Yeah, that's when mine was.
I hope to be okay for a while. I don't have to pay any more money for it. It will be someone booked like for 2 people.
Are you looking at the list, do you like? Don't understand. Shall I explain it later? Oh, I need my coffee cup. Yeah, it is full body. That's what she said last week. It was full body.
You don't necessarily have to have. Oh, if we were
PIA, is that here? Higher, here. Jesus, I'm gonna be scared now.
PIA.
You'll sit
PIA
on
on
Quetta or something.
We're not allowed to stay here, are we?
No, I'm gonna get my
Linda, if we did, if they wanted their abdomen done, how do we do it? Because by then they'll only have one towel over them.
You put that other towel on them.
Put the additional towel
You
on.
go and
don't
put that
you?
additional
And then
towel
you
and
put-
remove it.
Another
You go and
big
get a small one,
Oh,
like a.
small one.
Yeah.
Oh, and then you just pull the towel down a little bit. No, hang on, no. I can't remember, Linda.
Oh, right. I just done it. Okay, yeah, thanks.
Has it got the make on it?
Promethean.
Oh yeah.
Anyone have any idea how I can resync this?
I feel like it must. These move over.
Probably shouldn't be wafting my drink around.
I think this must slide across. Receiver phase.
What's happened to you? Just can't move it. It's cold today. Should we just give it a go or slide in it, or have you checked with somebody?
Yeah, I mean it is annoying because I feel like I know.
What are you trying to do then? Move it forward or?
Well, it looks like the whole screen can move across.
Oh, I see. So reposition it.
Yeah. It looks like it should be able to slide.
Do you want to push it towards your way?
But I feel like it's a button and you can't.
Those orange buttons you said, they look like they're something.
Yeah. Hey, wait a minute. I think I might have just done it.
That looks more centred, doesn't it?
Is it?
It's more central. Oh no, it's gone
Okay.
back.
Is it your foot?
Oh no, it's just cold in general.
Oh.
I did open
did it?
window because it was such a dry air. I don't know if you feel the same. It's just I feel it's very dry air.
Yeah.
And some fresh
Yeah, oh
air.
no, it doesn't feel cold in here. Yeah, it feels just right. But,
Yeah, I will close that.
Yeah, when you just had the other slide up on it, they had the pictures up on the left. Yeah, it's gone a little bit further over to the other side now.
Yeah. Unless you can turn the buttons on this.
11 now, so we'll have an hour of just doing these muscle revision. And then 15 minutes to set up, half an hour lunch, and then 15 minutes to just come back and prep, get in the zone.
Are we all massaging it at the same time?
No, so we always split it, so we always have 2 parts, because especially like with sickness, that's the way it works. So I've got, I'll write these in. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So Serena, Kim, and Charlie, you guys have got either staff or students, because they opened open clinic for today, but it only opened like for everyone like 2-3 weeks ago. Open clinic, so they would normally have 8 spaces, like 4 and 4, but they only had 5 clients book in this week, so that's why there's 3 left. But I spoke to one of the other lecturers, and they were like, "Oh my god, yeah, we'll happily have treatment." So that's how it works. So, Serena, Tash, you guys will be starting clinic at 2:15. So if you get ready, so these guys their treatment will finish at 2. So if you pack up all your work at 2, then you've just got 15 minutes to get ready for the treatment. So if you close all your curtains off and you just work at your station. And just catch up with theory, and you always have that time. I did record this earlier session, so you're welcome to watch that if you want anything. Sorry, stupidly long queue. Ridiculous.
Sorry. What kind of massage do you want? Sorry? What kind of massage do you want?
What massage is it?
What kind? Like back or legs or
Full body. You've got 1 hour. So you can miss abdominal.
yeah. I can go to abdominal or chest.
Unless you're really speedy, you won't have time to fit it in. So I'd recommend not doing the abdominal and doing regular back of the body, back of the legs, turn them over, front of legs, neck and chest.
Neck and chest as well.
That's full body. If you were to go to a spa and you book a full body, that's what you'd expect. So full body is about 20 minutes on the back, 5 minutes back of legs, 5 minute back of legs left side. That's 30 minutes. 5 minute front of leg right, 5 minute front of leg left. That's 40 minutes. About 45 here. Neck and chest. That's 5 minutes, and then that gives you 15 minutes for 5 minutes for feedback. Obviously, 5 minutes to get them off the couch and on the couch. That's your hour.
And further condition.
Yeah.
So we feel aromatherapy or just body massage?
You use aromatherapy, so you just choose one oil. Or if you want to give them aromatherapy and you want to, actually just go for full aroma. So generally with massage and aroma, aroma doesn't normally start yet, but the people that book in for aromatherapy will expect you to give them an aromatherapy treatment, and they'll be saying, especially if they've been here before, they will know that that you should know the oils and be discussing them with you. Whereas if they just booked body massage, it's just a nice treat. It's a bit more expensive for aromatherapy treatment, but it's a nice treat. No one's going to say, I don't want aromatherapy. And even if they were like, oh, I'm not sure about that, just explain to them. You could just say like, oh, well, the oils really benefit. We can make a really nice, like, calming scent for you. I'll let you smell it first so you like it. Because they might just be a bit like, a lot of people don't know what aromatherapy is. So just explain it. Bear in mind, you've only got to hit how many treatments for body massage?
30.
Yeah. How many you got to do for aroma?
100. No, 60.
60. So you're probably almost halfway there for massage. I don't know how many you are with aroma. So if I were you today, apart from AJ, yeah, everyone do body massage just to get you. Don't worry about the oils. Just get comfortable with open clinic. But from now, in the next few weeks, if you want to start doing aroma and start adding those hours to your aroma, then you can do that. And towards the second term, they definitely book them in. They stop booking them in for body massage, and they only book them in for aroma. Obviously, Kim, your client will be body massage, and so will Judith's. Eventually, we all go on to aromatherapy. But if you want to get a head start and do that, because that's what I want to do, so that you can hit your treatments. Yeah. Okay, so we're going to go through muscles of the head. Hallelujah!
Sorted itself out.
Technology is not normally my forte. Okay, so we're going to go through the muscles of the head. Everything else, this is the last piece of new information. Everything else you've already done. Okay, so looking at this, we'll go in a clockwise direction. What does epi mean? On top. So, on top of the cranius, we hopefully would get that. So this is a generalised area. So this just kind of incorporates this entire thing. This is a VTCT image. Well, I highly doubt this is going to be on your exam. But like I said before, get to know them all. Anything comes up, there should be no surprises. And then next week we do the nervous system. Then we're on to revision. And I'll get all the sheets printed out. Nothing is new information. And we just repeat and repeat until you finish it. But you pass your exam. Okay, so epicranius. We're comfortable with that. Any idea what aponeurosis is? We have gone through this. We had the palmar aponeurosis. If I said chewing gum. Does that make any sense? So an aponeurosis is like a sheet or a sheath of connective tissue. Think of a band of connective tissue, just like your IT band, but this is stretched out and pulled out, and that's what I was saying. Imagine you've got chewing gum and you blow a bubble and it goes all thin and see-through. That's what it should be like. So almost like you can hold it up to light and see through it. That's an aponeurosis. So this is a sheath of connective tissue that wraps around the base of the skull. That's your aponeurosis. You can see that it's white. So it's not pointing to muscle. That's how you know it's an aponeurosis. You have this spread across your palm, your palmar aponeurosis. You have an aponeurosis in the chest area as well. It's around your body, it's just a term meaning a sheath of connective tissue, like a thin, almost see-through structure, same material, but it's just spread out much thinner. Temporalis, hopefully like the temporal bone that we have. Occipitalis, base of the skull, so we've covered that one. Auricularis posterior, you have an auricularis anterior. So hopefully, we've got the anterior and posterior and also a superior. So obviously looking at auricularis, so looking at that ear area, superior is above, anterior is at the front, and posterior is behind. So you need to know the term auricularis, think auricularis ear. And if you look at these three, so you've got auricularis superior, anterior, and posterior. Hopefully you get posterior, because that means what? Behind. And then you're left with anterior and superior. Well, technically, yes, the superior one is in front. Anterior meaning front, right? But then if you're left with superior and anterior, hopefully you work out, well, one of them's the one above the front. So would you be happy with these three? Do you feel like, if you know auricularis, you could work out these three? Great. Okay, masseter, this muscle here, think of eater, like chew. So where you've got like the mandible underneath, and then you've got the masseter. Hopefully that would help you in that location. Think of like chomping down on something. Sternocleidomastoid. Sternum is where? Cleido is what? Clavicle. So sternocleidomastoid, if you put your hand on top of your forehead and push your forehead into your hand, you will see, can you see my sternocleido sticking out around here? That's your sternocleidomastoid. So some people, there's this really strained, you can actually do a sports massage technique on it. Have you gone through active lock technique? You contract a muscle, you clamp it and put in an artificial lock and then stretch it. So if you put your one ear to one shoulder, it's quite intense. You put one ear to one shoulder, whatever side you're contracting, you pinch, you've got to go in deep to the side and you pinch sternocleidomastoid. And then you stretch. This can be really intense for some people. It can lock out, and it can, if some people get really stressed, so they might just be. Can you see I'll try and if the neck's really straight, but you won't realise that some people are like that if they're really stressed generally, and they'll be like this. Also, if anyone's at a desk, so I've set my plumb line from here so I can see my alignment. Anyone's at a desk, generally the head is forward. The minute that head is forward, it means everything's holding so much more weight at the front, and so it can be really strained. So that's quite an intense one. That can be really, the next few days, that can be intense if you've done that active lock. But that's your sternocleidomastoid. So from here all the way down. Trapezius, we already know, so it's going from the base of the skull, and that's coming out to insert onto where? Where does the trapezius insert to?
Humerus.
Insert on the traps. Yeah, you're coming out to the side of the body. So you're not coming down, you're coming out to the side. Left scap does what? Elevates the scapula, shrugs the shoulders. This is the one, out of all of them, that's pretty hard to get your head around. Like this one. So, anyone, would you have a way of remembering that? Looking at the location. If you've got any ways of remembering.
It's kind of like the Adam's apple area, isn't it?
Yeah. If you have any ways of remembering, think of one. And then share it. So you've all got a way.
I'll just try and remember where all the others are.
Yes.
That's the last one. Yeah.
One of my students did have it. It kind of looks like platform plate. And when you said Adam's apple, you know when you swallow and you're and you take a gulp because you've been eating off your plate. And then it was a very tedious link, but it helps them remember.
Yeah.
So you just think of something. Okay, so you've got orbicularis oris and orbicularis oculi. Out of these two, just remember oculi, eye for eye. That's how you can remember orbicularis oculi. Wrapping around the eye there, you can see. Then you've got so you're left with orbicular oris. That is process. Yeah, process of elimination. Yeah, or OR for oral or mouth. Oculi, eye ends in eye. So there you go. The buccinator, you might see buccinator, buccinator. Do you remember what the term buccal means? Cheek. So there you go. You kind of know the rough location of it. One of my students was saying if you say boo, more the way your face changes. Auricularis anterior and superior have already gone through, and frontalis, we're there. So don't get overwhelmed by this, because actually, if you've got all the answers, like I've got them written down from you, and you're always going to have multiple choice, it's always going to be a drop-down menu, that if for some random reason they chuck this one in there, it's not going to stress you out, because that's the worst that can happen. You're in the exam, you think, oh my god, I don't know this, I haven't looked at this, just take a breath and take your time, because the answers are there. It's not like a random thing that you've got to pluck from your brain somewhere, however long ago. So, I'll hand, do you mind passing one to Anita, please? I'll hand this out. What do you not like? There we go. Cheating.
I remember.
I have plenty of spares. Guys, I've printed enough of those mock exams off that we can do another set tomorrow when I do it with the reflex group. So for you guys, so for Kim and Serena, yeah, we did the mock assessment, like questions of what we covered so far. We'll do it tomorrow, so don't worry. Actually, yeah, that's true, Serena. I'm going to go through everything tomorrow, all the reflex stuff. So you'll be here, won't you? Yeah. So if you want to do this afternoon, if you've got more theory to catch up with, we'll just catch up with that. Yeah.
I'll just do this at home then, just do some studying with what you.
Yeah.
I pretty much know quite a few of them because you've put them on there, haven't you, with other questions before? So
Yeah.
Them, so.
And I did record everything this morning, so I'll upload that.
I'll watch that tomorrow evening. Yeah, thank you.
What's the date today?
14th.
Thank you.
There's three, like 2 different ones, yeah? Because you've got 3 and then not a number next to the next little line, and then 4, 5 and 6. So it's 3, like 3A and 3B, I think.
Yeah.
Yeah.
Let's say yeah.
Yeah. That works.
Need 2 more minutes. Do you want to go through it? Are we finished?
names are on there. So I think like the hyponychium, I don't think that was on there, and the nail fold, I don't think that was on there either on the list. Yeah, because there's like a list on there, like then you can label them, but it's not there.
Oh yeah, because I said that on the PowerPoint. It's cut it off because it's Apple, and I printed it from the PowerPoint. Yeah, so yeah, I mean, just had a good self-test, I
I
guess.
wasn't sure because there was something. Yeah, I don't think I brought it with me. There's something I wasn't sure on as well. But anyway,
Yeah, I'll get them printed off next week though. I will write that down actually. So that's the name, isn't it? So I'll get you printed it with the answers next week. Okay, let's go through it. What did you get for? What did you get for one? Why this is going? What did we get for one? Serena, what did you get? Yeah. 2. Tash.
The orbicularis oculi.
Yes. Ada, 3.
So 3A is auricularis superior
Yes. Nice.
Um,
Una. Oh no, you go. 3B.
and anterior.
Yes. Auricularis anterior. What did you get for 4, Una? Yeah. And Charlie, 5.
The oryx one.
Yeah. What's the full word?
Orbicularis or
Yes. That's it. Auricularis oris. Kim, what did you get for 6?
The platysma.
Platisma. Yeah. Linda, 7.
well, after I put them all off, the only thing I was left with was that aponeurosis or something. But I don't
What
think that's,
does-
that's number 8, is it? I don't know.
That's number 8. Yeah.
That's number 8. Yeah, I've got it on number 8, but I don't know what number 7 is because I couldn't find anything on there.
What did you get, Maxine?
Funny enough, I didn't even realise that was one to answer. I thought that was just showing you.
Yeah, because I put that one on number 8.
Oh,
I've got
number
number 7
eight.
and I wasn't sure.
Epicranius. Epi means on top.
Oh, of course. See, I saw that one, but I just didn't suss that number 7 was one to answer.
Oh, okay.
Oh, it is there. It is there.
Yeah.
I didn't see that. Oh.
Where's that gone?
Epicranius.
Oh,
Yeah. So
I've
we've got
done that.
aponeurosis is number 8.
Yeah.
Serena, what did you get for 9?
Temporalis.
Temporalis.
Oh, yeah.
Tash.
Sorry, Leon.
10.
Occipital.
Occipitalis. Yeah. 11. Ada.
Auricularis posterior.
Yeah. Good job. We got all those 3 in the right order. Yeah. Nice. And 12. What did you get, Una? Yeah. And then 13. Charlie.
Oh. I haven't done that one.
What did you get, Kim?
Sorry,
It's
I
like
put
this.
Masuta, but obviously that's the wrong one because it was number 12.
What is this?
Sternocleidomastoidus.
Oh, that's it.
Sternocleidomastoidus. Yes. And then you've got Serena, next one down, 14. Trapezius, Tash.
And then 15 was the levator scapula.
Scap.
I got
Good work.
13 and 15 ran away.
But look how big the trapezius is.
Yeah.
Trapezius is a much bigger muscle than left scap.
I got trapezius, got that one.
So what did you get the wrong way round?
I put left scap for 13, although I didn't think it was right.
Well, for the
But can you see sternocleidomastoid? So you're going from the jaw, or like from behind the head,
Oh.
and you're coming to the clavicle. Therefore, it must move. It can't move the scapula if it's not attached to the scapula, can it? So therefore, it has to be, and you can see the direction of the fibres of the left scap going down towards the scapula, whereas that is not going towards the scapula, that's going anteriorly, isn't it?
I did think that.
So just to double check, if you wouldn't mind taking one of these and passing them on, they are the answers, so feel free to stick them up. So well done, that is, actually now you've looked at it, does it seem a little less overwhelming, that one?
So this one muscle you can see here by the It's between sternocleidomastoid and trapezius. As like that, like the fibers going just down. It has no name.
That's the left side.
That one? No, 15 was left. This one.
Yeah, the one inside.
Yeah, this one. Because that's it. I meant you got
15 was and that's that one's pointing to that.
Oh, you'll be scaling.
Oh, I see what you're saying. Yeah, that's another muscle there.
I would have thought. Guys, have you got this one? Let's do this one.
Yeah, me too. Me too.
Oh yeah, I see what you're saying. It looks like it's another muscle.
Yeah,
They should have got one. Yeah.
So that's definitely separate.
Me too.
Yeah, have a go answering these ones, guys.
Which one?
The one on the board. So you're doing the chest.
I don't know this.
Always seems to go to my mind. I was like, it's so long.
I'll see it at lunch.